Okay, so repeatedly, scientists are trying to find possible best result so that um, the result of each study will have the validation and the reliability of all the things that they are trying to produce on. And repeating studies or tests is called replication. And in the research, we have also that kind of way, the validity and reliability. Okay, and in science, we always use this deductive and inductive reasoning. Of course, we all know that inductive reasoning is specific to general ideas that we are trying to serve from. No, so it is a reasoning from many observations to produce a general rule. For example, we have an example here that we conclude that all organisms are made of cells because in general we are trying to find the reason out that the organisms are made of cells. So we conclude that all organisms are made of cells, to be specific. No? And to define deductive reasoning, we have the logical reasoning from general to specific. No? We have to understand that inductive reasoning are specific to general and deductive reasoning is general specific. No? For example, if all organisms are made of cells and humans are organisms, then humans should be composed of cells. No? You can see in this example that we start from the general going to the specific. No? From all organisms going down to the humans. No? And it is important to recognize the role of insight, creativity, and luck in research so that there is always the use of hypotheses and theories to support your inductive and deductive reasoning. Again, hypothesis and scientific theories. What are the difference between the two terms? No, we all know that hypothesis is an educated guess, and to prove the hypothesis, we have to find related resources, other studies to back up the framework of the educated guess that we have already planned about. No, and for a theory is already considered as a major study that is already proven by a lot of studies or series of experiments. And theories are already reliable, unlike hypothesis that is not yet proven to be reliable. Hypothesis is somehow personal because it's not yet already proven. When the hypothesis is already proven and a lot of backup was already planted into the hypothesis, that's the only time that we can consider that already a theory. From a theory, we will be deriving laws out of those theories, and the laws are already very, very much reliable than the theories. Because theories are still in the middle ground of the things that we already know universally. But when we talk about laws, it encompasses all the things that mankind knows all about it. No? Everyone knows about that law, and that law cannot be easily taken down into the minds of the people. So if we have the hierarchy of scientific knowledge based on the sciences be proven, we can start with hypothesis as the primary thing to think about the problem. And out of the hypothesis, we can conclude that the second highest form of thinking is the theory, which is reliable already. And from the theory, we can conclude if the theories are very much reliable and everyone knows about it, it will become law. No? So hypothesis, theories, and eventually it will become law. when everyone will acknowledge that this is reliable and true, valid, everyone, the universe or mankind. So that's how the body of knowledge works in terms of spiral approach. No? We have also probability that we need to understand that there are certain things and measures about the body of knowledge that we will um, take into considerations, because there's a lot of things that occur phenomenal and not phenomenal. No? Example, uh, usually ecological tests are considered significant if the probability is less than 5% that the results were achieved by random chance. The amount of confidence scientists have in the results depend on the sample size as well. No? A large sample size is better than a small sample, because the moment when you get the smaller sample size, of course, meaning to say the probability of the chance of getting how reliable and valid of the study that you are getting is a little more uh, little or less effectivity than the large sample size. No, for example, if you have a million, no, total population, if we get a million sample size, if we get that from a million sample size, we can only get at least 10% of it, so that we can start the probability of the confidence level of the required by the scientists, no, be valid. No? Out of those populations, out of those sample size from the population, we can already conduct a reliability and validity, and then proceed to the test or the testing of uh, of the study, no? So that it will become valid and reliable. Remember, the larger sample size is better than the smaller sample size. So take note, if you have research paper someday or in your fourth years, no, it is better to have the large sample size when we talk about quantitative research. And the smaller sample size are questionable because, of course, the little sample size, the little the data that you have. It's the only thing that the probability will take place. No? And we have also experimental designs in sciences. In experimental designs or research, we have the controlled study, we have the blind experiment and double blind experiment. And controlled study is a comparison of treatment group to a control group which has not received any treatment at all, meaning it is controlled by the researchers, of course. No? And when we talk about blind experiment, researchers doesn't know which group has been treated until after the data has been analyzed. When we talk about double blind experiment, neither the subject nor the researcher knows who is the treatment group, unlike the control group that the researchers already know which group is control, no, or the be treated than the control group. No? So oftentimes experimental designs or researches are found in medical fields or societal research or social studies research, no? Because we analyze deeper, and we have a lot of sample sizes in experimental design, unlike in quantitative or qualitative rather. We just have at least 12 sample size for interviewers to be interviewed on, and it will take place already. So the data will be gathered, those only meager amount of time and people. Now, sciences also have this variables. No, in each study there is one dependent variable and one or more independent variables. The dependent variable is affected by what happens to the independent variable, of course. No, in example, in mathematical equations, of course, if we have the y-axis and the x-axis, no, the dependent variable on the vertical y-axis is and the dependent variable is on the horizontal x-axis. Meaning to say, whatever it is that the horizontal axis or the x-axis do will have an effect to the dependent variable vertical y-axis. Now we will go to the systems already, and we already discussed what are sciences, what are the parts of sciences and the functions of sciences in systems thinking. Now, if we have to define again the systems, if you remember last time, we defined system as a network of interdependent components and processes with materials and energy flowing from one component to another. And each of minute details of simple task has a function to do. And as an overall, it will act as a system. They are central concept in environmental science and other sciences as well. For example, ecosystem, climate systems, geologic systems, and economic systems. Those are partly some of the concepts that we try to link the principles of system thinking. Now, the characteristics of a system is, or it can either be a closed or open kind of system. What is this closed and open kind of system? Closed, of course, to the word itself, closed, it is self-contained. No matter the energy is inside, it cannot go outside. It exchanges no matter or energy with the outside. Unlike the open, it exchanges matter and energy from the surroundings. So it's open to all of the variables present outside. And we have also the positive feedback loop and the negative feedback loop. This positive feedback loop is self-perpetuating, or as an increase in variable, it leads to further increase also in the system. While the negative is it suppresses and changes within the system and helps to maintain stability in the system. Everything is also always found in a system because it is the characteristics of a system. We may not see it directly to the other systematic body of knowledge, but it occurs most of the time. Emergent properties are characteristics of a whole or functioning system. For example, a tree is more than just a mass of stored carbon. It also provides structure to the forest, habitat, shade, holds soil in place, etc. A system is more than the sum of its parts. Now, the goal of the system is be standalone, even though there is only one thing to be functioned off. Because the moment when we cut off the part of that kind of that system, automatically that function will not part of the system at all. Because in a system, we need all the minute details in order for a system to work. For example, again, if we go back to the tree, the tree is just only a physical thing that we can see naturally, but in reality, it holds a lot of things. It gives off oxygen, it absorbs carbon dioxide, and it gives shade to the people. It holds the soil in place so that there will be no landslides. If we come to think of it, tree is just a tree in our meager eyes, but in reality, there's a lot of system functioning in that kind of natural object. So I want you to think of every object that you see that has a function in all aspect. For example, the computer. The computer is only just a computer, but in reality, there's a lot of things that the it functions for us, no, to help us in our day-to-day lives. No? The electric fan, no, the air condition, the light, house, any object that is present, you can see in your surroundings. It has a system and it has characteristics. Now, the stability of system is we have equilibrium. It is a dynamic state in which system is stable over time. We have also disturbance, periodic destructive events such as fire and flood, which is somehow natural, inevitable, phenomenal. We have resilience, the ability of system to recover quickly from disturbance. We have state shift, a severe disturbance in which the system does not return to normal, but instead results in significant changes in some of its variables. For example, if the wood is being is on fire, no, eventually that wood will become charcoal, and it has already undergone the state shift, no, from a wood to a charcoal, which is very useful for a cooking, no, for giving us heat in times of cold. So those are the stability of systems. Okay, so we will end here, and I hope you learned something today. And there is an activity for you to answer this. Kindly check out your answers. Okay, so thank you very much for listening, and hope you learned something today. God bless everyone.